Hi everyone, in this session we are going to learn calculation of equivalent mass of different substances. First of all, what is the need of calculating equivalent mass of any substance? In chemical reactions generally, fixed quantity of substance is combined or will displace with another substance to form products, right? In order to know that fixed amount of that substance in grams, you need to calculate equivalent mass. That's why equivalent mass of any substance is represented by gram equivalent mass. Okay, check out these formulas which I have written for the basic purpose. If you want to calculate equivalent mass for an acid, so you need to focus on number of replaceable H plus ions. Here you can say it is the basicity of an acid. You can say like that. But it is the easy way to remember number of replaceable H plus ions if you are calculating equivalent mass of an acid. If you are calculating equivalent mass of a base, you need to focus on number of replaceable OH minus ion. Molecular mass of base by number of replaceable OH minus ions. If you are calculating equivalent mass of a salt, molar mass of salt by total positive or negative valency. We'll check out with so many examples, don't worry. Equivalent mass of an oxidizing agent or reducing agent. Molar mass of oxidizing agent or reducing agent divided by number of electrons transferred. In redox reactions, what will happen? Oxidation or reduction, right? If it is oxidation, it loses electrons. If it is reduction, it gains electrons. So focus on that number of electrons transferred during the reaction. Let us start with a simple acid HCl. How it is going to dissociate? H plus Cl minus, right? So here the formula is molecular mass of HCl divided by number of replaceable H plus ions. What is the molecular mass of HCl? You all know that 36.5. What are the number of replaceable H plus ions? Only one. So here for HCl, equivalent weight and molar mass of HCl is the same. Then again you can calculate for H2SO4. Here how it is going to dissociate? 2H plus SO4 minus 2, right? So when you calculate equivalent mass of this acid, what is the molecular mass of H2SO4? 98, right? 98 divided by number of H plus ions. Here replaceable is 2, so you'll get 49 for H2SO4. In the same way, CH3COOH, acetic acid. Here also you will have only one H plus ion that can be replaceable. So equivalent weight and molecular weight of acetic acid will be the same. Suppose for H3PO4, when it is reduced to H3PO4, when it is reduced to HPO4 minus, that means it is dissociated into 2H plus and HPO4 minus. In this, how many replaceable H plus ions we have? 2. So HPO4 divided by 2 for the equivalent mass. That is also is 98 by 2. Okay, if you have a reaction like H3PO4 plus CaOH twice gives rise to CaHPO4 plus 2H2O. Okay, so when you want to calculate H3PO4 equivalent mass here, what will be the formula? So how it is dissociated? HPO4 minus. That means you have in this way it is dissociated. You have 2H plus and HPO4 minus, right? So you have two replaceable H plus ions again. So that will 98 by 2. You will get 49. Okay, this is for acid. If you are calculating for a base, take simple any base, NaOH. So it will dissociate into Na plus OH minus, right? What is the what is the equivalent mass formula? Molecular mass by number of replaceable OH minus ions. 40 divided by how many number of OH minus we have? Only one. So for NaOH, it is the same. If you have taken calcium hydroxide, it is going to dissociate Ca plus 2 and 2 OH minus. Right? So here you have 2 OH minus ions that can be replaceable. What is calcium hydroxide molecular weight? 74 divided by, you have 2 OH minus ions by 2. You will have 37. In the same way, aluminum hydroxide. Here how it is going to dissociate? Al plus 3 and 3 OH minus. Right? You have 3 replaceable OH minus ions here. What is aluminum hydroxide molecular weight? 78 divided by 3, you will get 26. 26 is the 26 grams, 36 grams. It is the equivalent weight of aluminum hydroxide. That is the equivalent weight of calcium hydroxide. Okay, in this way you have to calculate the equivalent mass of any base. Okay, if you want to calculate equivalent mass of any salt like NaCl, first of all, it is the easy one. How it is dissociated? Na plus Cl minus. Here the total charge is plus 1 or minus 1. Only 1. So molecular mass of NaCl divided by 1 only. 58.44 by 1 only. Okay. If you have taken any other salt like calcium chloride, what is the charge here? Ca plus 2 Cl minus 2 Cl minus. So the total charge is plus 2 or minus 2. So calcium chloride molecular weight is 110.98 divided by 2. This will be the equivalent weight of calcium chloride. In the same way, aluminum chloride, here how it is dissociated? Al plus 3, 3 Cl minus, here plus 3 or minus 3. You can calculate the equivalent weight divided by 3. So this will be the equivalent weight of aluminum chloride. So when you have seen in any reaction like Na2CO3 plus 2HCl gives rise to 2 NaCl plus H2O plus CO2. So you need to calculate sodium carbonate equivalent mass here. So equivalent mass will be here. How it is going to dissociate? Simply you can say Na plus 2Na plus CO3 2 minus. So plus 2 or minus 2. It is the total negativity or positivity. So you can calculate the molar mass of NaOH which is 106 divided by 2. So this will be the equivalent mass of NaOH. In this way, if you have taken any salt, you need to concentrate on the total charge, negative charge or positive charge of that salt. Okay. So next, oxidizing or reducing agent. So if you want to calculate any oxidizing agent or reducing agent, or in any oxidation or reduction process, if you want to calculate equivalent mass of any substance, you need to focus on the electrons transferred, okay, during the reaction. In NaIO3, it is reduced to I minus. Here example is. So what is the oxidation number of iodine here? X equal to 5. How can we calculate? 1 plus x minus 6. So you will have plus 5 here. Okay. Here minus 1. 2 plus 5 becomes minus 1. So how many electrons transferred here? 6 electrons. So equivalent mass of this NaIO3 equal to molecular mass. What is the molecular mass? I have already calculated. 198 by 6, which is 33. This is the equivalent weight of NaIO3 in this process. If it is reduced to iodine, which is NaIO3 reduced to I2. So here it is plus 5, right? It is 0. So how many electrons transferred? 5 electrons. So equivalent mass will be 198 molar mass of NaIO3 divided by 5, which is 39.6 something. So this is the equivalent weight of NaIO3 when it is reduced to I2. As earlier said, the equivalent weight of any substance is not always the same or constant. It depends upon the type of reaction in which it is going through. Okay, so let us see for oxidizing agent. Oxidizing agent. What is oxidizing agent? Which is used for the oxidation and itself reduced, right? If we have taken the popular example manganese, I am writing directly the acidic medium reaction because it is the calculation of equivalent mass, no? Plus 5 electron gives rise to Mn plus 2 plus 4 H2O. Okay, here what is the oxidation number of manganese? Plus 7, right? X minus 8 equal to minus 1. X equal to 7 plus 7. Here it is 2. So how many electrons transferred to become Mn plus 2? From Mn plus 7, 5 electrons transferred. So what is the equivalent mass of MnO4 minus here? Molecular mass of permanganate is M158 by 5. It is 31.6. Okay. In the same way, you can calculate for the dichromate also. In that also, you will get molecular mass of dichromate by 6. Okay. If it is reducing agent, like I'll write equation FeSO4 plus H2SO4 plus O Fe2SO4 3 plus H2O. So you can directly write this equation like Fe plus 2 oxidized to Fe plus 3 by losing 1 electron. So what is the equivalent mass here? Equivalent mass equal to molecular mass of FeSO4, that is 152 grams. 152 divided by how many electrons transferred here? Only 1. So the equivalent weight of FeSO4 in this reaction is 152 grams. Okay. So this is reducing agent because reducing agent itself oxidizes, right? Oxidizing agent itself reduces. So based on that reduction and oxidation, you need to focus on the number of electrons transferred during the reaction. Then you can calculate the equivalent mass. Okay. So next time, based on this definitions, I'll make a video on normality calculations. How to calculate normality, the strength of solution in normality. Okay. Thank you. If you want to calculate